Hey everybody, and welcome back to another fun and exciting pre-calculus class. Today we're going to be jumping into chapter number 8, getting into the second half of the book. And hey, it's all downhill from here. So you made it to the top of the mountain, and now we're going to head down the mountain. Not saying that it's going to get easier. I'm just saying that you've accomplished half of the book, and now we're headed down the mountain. So today what we're going to be talking about is solving triangles, kind of using Pythagorean's theorem, if it's not a right triangle. So maybe you thought you could only use Pythagorean theorem with a right triangle. You're kind of correct, but there are ways that we can manipulate, change, and use Pythagorean's theorem with our sine, cosine, and tangent to solve triangles that are not right triangles. Here we are in chapter number 8, solving oblique triangles. Notice there's an awesome Bible verse here. Give instruction to a wise man, and he will be yet wiser. Teach a just man, and he will increase in learning. Proverbs 9:9. I was just telling my mom this last night. My mom and I were talking on the phone, and I said, Mom, I can't teach a student that doesn't want to learn, but I can really teach a student that wants to learn. Notice the verse here says, if a wise man, if you give instruction to somebody who is wise, what are they going to do? They will become wiser. If you teach a just man, he will increase in learning. So be that person. Be that person who wants to learn, who has a desire to learn. I can't teach. God can't teach. Nobody can teach somebody who doesn't want to learn. God can continue to try to do things in your life, your teachers, your parents, whoever, they can continue to try to teach into your life, but if you won't learn, if you're obstinate and you just say, no, I'm just not going to learn, then you won't learn. But if you have an open mind, if you want to learn things, then you will increase in your understanding. So awesome Bible verse. It's a great place to kind of hit that right here because we just, first semester is rough. I mean, some of those lessons, they're tough. But here we go in the second half, jumping back into this book and just focus on, don't focus on pre-calculus. Don't focus on any of the classes. Focus on this. Focus on learning. Focus on understanding. Focus on just increasing your ability to learn things. And the Bible verse here will be true in your life. You will increase those things. If you have a desire to, then God will, give that to you in your life. All right, jump down here to 8.1, the law of sines, the law of sines. So here's what we're going to do. When we solve an oblique triangle, remember, up until this point, we didn't have a way. We could only solve the right triangles, and we use Pythagorean theorem for that. But when we solve an oblique triangle, there's this special formula that we can use. It's right down here, and we'll jump to it in just a second. That what it'll do is it will allow us to use a form of the Pythagorean theorem to solve the oblique triangle. It's called the law of sines. All right, so here it is. What we're going to do is we're going to take A over sine of A equals B over sine of B equals C over sine of C. And you might say, that has too many equal signs. Shouldn't there be like a plus or minus or something? No, what these are is these are ratios, right? Proportions. So this is a ratio of side A to the sine of side A. This is a ratio of side B to the sine of angle B. This is a ratio of side C to the angle, the sine of angle C. And so you take these, and so in other words, this ratio, the ratio of A to A, equals the ratio of B to B, equals the ratio of C to C. So what you do is you plug in your known values to these things, work it, and then it will kick out the answer to the missing side. Okay. And maybe that sounds complicated right now, but it's not. And in fact, this is one of, in my opinion, one of the, I hate to use this word, easier lessons in the book. Okay. So look over here at this triangle. What's actually going on is we've taken an oblique triangle. So A, B, C, this big triangle out here, we've taken the oblique triangle and we've added a height. That's what HE stands for, is height. So this is what this H stands for, is height or altitude. So we've taken basically from the top, from the C point, and we've drawn a straight line, okay, perpendicular to the base. That's the definition of a height or an altitude. You learned that in geometry class. So we've drawn an altitude, and here's what we created when we did that. We created two right triangles. From any oblique triangle, you can create a right triangle in them. So what we're going to do is we're going to use Pythagorean's theorem by creating two right triangles. And when you do this, what you end up creating also is you end up creating two right triangles that share a side, okay? So this right triangle, A, C, and then we could call this D down here, ACD, this triangle right here, shares the side H right here, the height, with this right triangle, BCD. Again, I'm creating the letter D. They don't have the letter D here. But we create two right triangles. By doing that, when we put all of this stuff into proportion, what we're going to find is we're going to find our missing sides or our missing angles, whatever we're missing, okay? Now, notice right here, one more thing before we kind of jump into the actual work for this chapter. If we're letting S stand for side and A for angle, that's what we've done in geometry, right? Angle, side, 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 angle, 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 all these different things that we learned in geometry class. And if we do this, then what we can do is we can solve missing sides, just like we did in geometry class with Pythagorean's theorem, with all the other things we did in geometry. So how do we do that? Angle, angle, side, angle, side, angle, side, and side, side. These are 5 types of solvable oblique triangles. Angle, angle is not permitted because a side is needed to solve a triangle. In other words, Pythagorean's theorem doesn't work if you don't know one of the sides. You have to know at least one of the sides in order to use it. So we can't use angle, angle. And that should make sense to you, right? Because if it's angle, it could be, any size. Just, it's almost like you take it and you just blow it up or shrink it, but you're not changing the angle size. So you do need one of the sides, and what that does is that restricts the other sides once you know one of the sides. All right. So when we do the law of sines, notice it says it's useful for solving the first 3 types of oblique triangles. So it's useful for solving angle, side, angle, and side, angle. We're going to have to learn something else for side, angle, side, and side, and that will be later in the chapter. But this is going to work for the first 3 types of triangles. Here it is. A, that's side A. These top ones are sides right here, and these bottom ones are angles. How do I know that? Well, the sides are small letters, and the angles are big letters. So side A over angle A equals side B over angle B equals side C over angle C, or the sine of those angles, okay? And then you can do it the same. You can just flip your triangles. Remember, these are proportions, so these would work either way. You could flip your ratio, numerator, denominator, but you would have to do it consistently all the way through it. You can't have one being side over angle and one being angle over side. It's not going to work. So you'd have to have all the angles on top and all the sides on the bottom, or all the sides on top and all the angles on the bottom. Either way. Steps for solving. Let's run through this real quick, and then we're just going to do a couple of these. Draw an accurate diagram. So basically, you want to just draw whatever, if the problem doesn't give you a diagram. Even if it does, I like to draw it on my paper. But always draw yourself a diagram. Number 2, make a table of the unknowns. What am I missing? Okay. I like to draw a table of the knowns too. That way I know what I have and I know what I'm missing. Write an equation with only the given values. So in other words, we're going to plug in that. I almost like the word plug in to the formula better than what they say here on number 3. Number 4, we're just going to solve it. Okay, and then number 5, we're just going to repeat the steps for anything else that we're missing. Notice this is the key to the whole deal right here. Avoid using calculated values when possible. You always want to go back to the given values, Okay, and I know it's going to be hard because you're going to want to go back to your calculated values because you're going to be like, oh, I already know this. Well, but you rounded it off, remember. So whenever you round off a number, don't use that number. Go back to the given number, and then you can check your solutions as well. Okay. All right, let's jump over here. Let me kind of show you this here on the screen as well. This thing here says to use to find the angles, and really, to be honest, you could do it either way. It doesn't really matter. And then use to find the sides, and it's just kind of that way. It's just in your mind, but you can. It doesn't matter which way that you use this, but hopefully that will help you out. But you can see here, I've got in pink color, I've got the angle, so A, B, and C. And so that's going to be your capital letters up here on the top or down here on the bottom of this one. And then the small letters are the sides. So the one across from A is small a. The one across from capital B is small b. And the one across from capital letter C is small c. Now don't forget that you would also have, in order to solve this, you would also have an altitude. So this, in this case, this would be your altitude, and you would label that H. You don't need to label that. It's just in the back of your mind, that's how you're solving this, is because you're creating an extra, two right triangles. You don't have a right triangle to start with, so you're creating two right triangles. Okay, let's jump into this. Let's try to solve one. Here we go. This is in your book on page 161. 161. So we have A, B, and C here, and we have some known information. The problem gives us side A, and angle B. Well, what I would like to do here is I would just kind of write, what am I missing then? So I'm missing B, and I'm missing C. I'm missing those sides, and I'm missing angle C. It's a little bit complicated with little c and big C because they look the same. So, you can differentiate that on your paper, but there we go. Now, the easy part right here is angle C. Like, we don't even need to mess with any formulas to get angle C, do we? All we have to do is know that a triangle has 180, and then we have 40 plus 65, that's 105, and so we just have 80 minus 105. So this is going to be 75 degrees. All right, that was easy. So there we go. We have 1/3 of the problem solved already because we got our 75 degrees. And you're going to need that, okay? So now what I would do, I just kind of like to come over here and I just kind of like to fill in stuff of what I know. So this is side A over here. Why? Because it's opposite of the angle A. And so that's going to equal 6. And then B over here, this is we don't know. C over here, this is another we don't know. This angle up here is going to be, angle C is 75 degrees. Angle B is going to be 65 degrees. And angle A is going to be 40 degrees. Okay? All right, so we've got lots of information, lots of things that we do know. But again, these are the ones that we're looking for right here. So because of that, now we need to fill them into this formula up here. Okay, so let's go ahead and do that. And which one are we going to use? Well, we want to use the one that we know two. Okay, so in other words, we know A and A. That's the one that we're going to use. That's the one that we want to put everything else with. So with A, we're going, and we can do it either way. It doesn't matter. So we'll do sine of 40 degrees over 6 equals, and we'll do the B one first. Doesn't matter which one you do first. We'll do the B one. So we'll do the sine of 65 degrees over, this is our X. Okay, that's we're gonna have to do this twice because we have two unknown values. And now we just solve this. It's just a ratio, just proportions right here. Okay, so how do you solve proportions? Remember, we do the means, these guys, equals the extremes when we multiply those together. So what we're gonna do is we're gonna have sine of 40 degrees times X equals 6 times the sine of 65 degrees. The goal of this is to get x by itself, so we could just divide both sides by the sine of 40 degrees. That's going to cancel, and then we're going to get x equals this right here. Plug it into your calculator. 6 times, and really I probably need to put parentheses over this whole thing in order for it to come out correct. 6 times, and then we will do the sine of 65, and then I'll hit a double parenthesis, and then I'm going to divide that by the sine of 40. So sine of 40 degrees. Hit my parenthesis again, and we'll just hit equal, and that's going to tell me what my side equals. Now look, it gave me like a big decimal answer, right? So 8.4, okay, so just write that out, 8.4. You're going to have to, typically the problem will tell you what to, how far to take that before you round it off. In this problem, it gave us the answer. Notice right here, it gave us a equals 6.0. Basically, that's telling us right there that it wants one decimal, or it wants two significant digits, however you want to look at that. So I'm going to put in 8.5, because I'm going to round this off to 8.5 is going to be the B side. So come over to B, and 8.5 would be the correct answer on B, 8.5. And we're going to do the same thing with C. All right, now notice here I go back to my A information, okay? Why did I go back to my A? Why not use B? Because now I have both parts to B. I have the B angle and I have the B side. So why not go back to B? Because if you remember from the steps that we talked about, that is an approximated value. I rounded that off. So we're going to go back to A, and then I'm going to jump to the C. And so now this is not an approximated answer. Why not? Because we just subtracted that from 180 and we got 75 degrees. So we didn't get a decimal, we didn't get a repeat, we didn't get an irrational number basically. So we can use this. And so 75 degrees, so we're going to have the sine of 75 degrees over, this is going to be our x this time, and we would just do the same thing. Plug that into your calculator, and that is going to yield x equals 9.01, or 9.0 would be this one. So C is going to be 9.0. All right, so there's your A, B, and C, and I guess we could write over here 9.0. So we have everything. There's our chart of unknowns next to our chart of knowns. All right, real quick, I think I can squeeze this last example in here. Okay, look here on page 162, real quick. A surveyor determines that this angle C right here is 37 degrees and 20 minutes. That's important right there that you remember what that is. 37 degrees and 20 minutes. And then this angle, angle A, right here at Dave's cabin, is 40 degrees. So just set it up in a triangle. Don't worry about Dave's cabin and Sean's pier and all this other stuff. Don't worry about the river name. That's all just extra information just to kind of mess you up. So just worry about the triangle. And then you have 700 feet right here. So let's jump back over here, and I've got this all set up in triangle form. And so what we want to do is we just want to plug in the information where we know it. So angle C is 37 degrees and 20 minutes. Angle A is 40 degrees. Angle B, then, that's the one that we can figure out out of the 180, right? And so now this is a little tricky, and you can use your calculator for this. Make sure that you're in degrees when you do this. But you can actually subtract that, or you can just subtract it like this. Just do 40, basically 0, 0. And then 37, and then 20. Add those up and then subtract from 180, 0, 0. Okay, and when you do that, what you come up with, 102 degrees and 40 minutes. The other known that we have is we have this B side is, okay, the side across from angle B is 700 feet. Now, what we're looking for, so this is B equals 700 feet. We're looking for A. and we're looking for C. Okay, so we already found angle B. It was 102.4, 102.40. And then we're looking for side A and side C. Plug it into the formula, plug it into your calculator. That easy. We should be able to do this. So what are the ones that we already know? Well, we need to be using the B and the B. And you say, but the B, we calculated this. No, we still didn't calculate it because we subtracted it from the 180.00 and we got that to work out. So this is an exact figure right here, so we can use it. So our B numbers this time are going to be, we'll do 700 on top this time, and it doesn't matter. So 700 over 102 degrees and 40 minutes equals, we'll start with C. So we'll start with C over, we'll call that X actually. X over C is 37 degrees and 20 minutes. And obviously here, this is we're dealing with the law of sine, so this is the sine of this and the sine of this. I should have put that. When I'm doing these, a lot of times I don't write the sine of, I just, do it when I plug it into the calculator. So next thing that we want to do is just go ahead and do this, right? So it's going to be X times the sine of our 102.40 equals this right here. So 700 times our sine of 37 and 20 minutes. Okay. And then you would just divide both of these by the sine of this, divide by the sine of 102 degrees and 40 minutes. And that's going to cancel over here. So we're going to get X equals, we just need to solve that out on the calculator. All right, now I do want to show you this on the calculator real quick. So everybody's calculator is going to be a little different right here, but when you get these degrees and minutes, what you want to do is on your calculator, so we're going to put in 700. All right, and actually I need two parentheses right here because I've got a couple things going on here. So 700, close my parentheses, times the sine of 37 degrees. Now, on my calculator, I've got this button right here that does degrees, minutes, and seconds. This does it all. So what I do is I click it once for degrees, and then I type in, my next one is 20 minutes. And I'm going to hit that same button again. Now, it's going to kind of look the same. It puts like a little square little thing next to it, but that's okay. It's going to calculate it just fine. What I did was I told the calculator that this is 37 degrees and 27 minutes. Now, if I had seconds, then I would put another one here. I'd put another number with another one of that button push right there, that degree button push, and that would give me seconds. But I don't have seconds in this case, so I'm going to close my parenthesis. And I'm going to close my parenthesis again, saying that the top of this fraction is done. And I'm going to say that this is divided by the sine of 102 degrees, hit my degree button, and then 40 minutes, and then hit my degree button again, and that's going to tell it that it's minutes. I'm going to close it off, and I'm going to hit equals. And there's my answer, 435.10, so 435.1 would be my answer. So 435.1. I would just do the same thing again. I won't show it to you again. I would do the same thing again for my other side, for my A side. Well, that's all I have for you. I hope you learned something there in that lesson. Lots of stuff going on, but it's actually fairly simple. Once you get it kind of figured out, that you just plug in and, your calculator does the work for you, but you have to get it into the right format so that the calculator can do the work, right? So if you missed anything there, slide it back, watch it again. Hope you were able to understand that. And do some of these practice. Practice makes perfect. So go to these practice problems and just start doing some of them and practice with those. Make sure that you remember, don't use calculated values to get the next value. Always go back to the original values where you knew both of them. You knew the angle and the side for either A, B, or C. Okay? That's all I got for you. See you later. Have a good one. Bye-bye.